Hi, in today's video, I'm going to be walking through section F of our catalog, that's float operated level controllers. I'm going to be talking through the Gen 3 as well as the pneumatic level switch. I'll be covering operation, application, and some troubleshooting. The Gen 3 level controller is in section F, float operated level controllers. I want to get something out of the way in the beginning of this video. The displacers used with the Gen 3 are not technically floats. They're displacers. So if they were not connected to the Gen 3 and you dropped it in water, it would not float, it would sink. The floats on the level switches are floats. They're hollow, they're filled with air. I wanted to get that out of the way. Sometimes people refer to the displacers as floats. But anytime somebody's talking about a Gen 3 or our previous version Gen 2, they're talking about the float of that controller. What they're really saying is displacer. But the applications where this is used in is on any liquid accumulating vessel. It could be separators, heater treaters, all different kinds of separation equipment. Anywhere you're wanting to control the liquid level inside of that vessel, that's where you'll use our Gen 3 level controller. In this picture, you can see some of the applications that we use the Gen 3 level controller in, as well as the level switch. This is a gas production unit. You can see there's two liquid level controllers, or two Gen 3s, and they're each operating their own high pressure control valve, being used as a dump valve in this application. The level switch in this application is being used as a low-level shutdown. So on the other side of this gas production unit, it's not really shown in this picture, but there is a heated vessel on that side that heats a coil of tubing up to preheat the flow stream before it takes a pressure cut. But there is a burner tube in there, and it has to be covered with liquid. If that liquid level drops below the burner tube, that can cause issues. It can cause damage to the burner, and so you want to make sure that the burner tube is completely covered with liquid, and that's the job of a pneumatic level switch in this application. If liquid level drops below where that level switch is installed, it will shut down supply to the burner, to the rest of the controls, shutting down the piece of equipment so that way damage is not caused to the equipment. Here's another example of the Gen 3 and level switch being used on a three-phase separator. It's a vertical separator. Both the oil and the water dump valves are being operated by the Gen 3. The oil is on the top, and then you see the water below that. So this would be a scenario where this is being used for the water side in interface control. So the displacer is sinking through the oil and only operating in the water. And then the oil is top level control. So it's only sensing the oil level inside of the vessel. The level switch in this application is being used as a high-level shutdown. So on the gas production unit, it was being used as a low-level shutdown where if the liquid level dropped below it, that was the failure scenario. In this case, it's being used as a high liquid level shutdown. So if the Gen 3s, either one of them, failed for any reason and liquid level began to rise in the vessel, instead of that liquid ending up going out of the top of the vessel with the gas, once it hit that level switch, it would shut down the controls or the inlet to the vessel. That's a pretty common application with the level switch, high and low liquid level shutdowns. The output of the Gen 3 level controller can go to any control valve. Any control valve that requires 30 psi signal to operate. So that could be our high pressure control valves, it could be our low pressure control valves, or anything in between. just as long as it takes a pneumatic signal to actuate that valve. 30 psi up to 45 psi. But if you're using Kimray product, 30 psi is all you need to supply the level controller with to operate the dump valve. With the standard float, this can operate in both water and oil applications. It's important to keep in mind that in interface level control, where you have oil on top of water and you're trying to control the water level, the specific gravity differential between the water and oil has to be at a minimum at least 0.2. So if your water is fresh water and it has a specific gravity of 1, that means your oil needs to be at least 0.8 or lighter, or have that specific gravity. That's with the standard displacer. We do have other displacers. We have a 2x20 displacer as well as a 3x12 displacer. They give more surface area, more displacement, and that one has a minimum specific gravity differential of 0.1. So if your oil is really close to the gravity of your water, we suggest using those larger displacers to control interface level. If you're using the Gen 3 in a connection that's a 2-inch connection, just be aware that the 3x12 float won't fit through that 2-inch connection. You have to have the ability, either with a man way or some way, to connect that 3-inch float, or 3-inch float. See, I said it there. 3-inch displacer to the Gen 3 as you're installing it. So just keep that in mind as well. So we have a 2x20 float. That's much longer than our standard displacer. If you're working with a narrow vessel that has a narrow internal diameter, make sure it's large enough to where that float or that displacer can get into the vessel, and if it's in the vertical orientation, drop down properly. Because if you try to put that in a really slim vessel, or maybe a 12-inch vessel, it won't be able to be installed because it'll hit that back wall and not be able to drop down and get fully installed. So just keep that in mind when you're using the longer or wider displacers. These controllers can be set up for snap or throttle action. Most dump valve applications are going to be snap acting, especially if you have erosives like sand or other solids in the flow stream. You don't want to use a throttling controller because that will keep the valve cracked open, the dump valve cracked open for longer periods of time, which just leads to erosion a lot faster than if you have a snap acting controller that opens the valve fully and then closes the valve. Another application where you would use a snap acting controller would be if you're metering your fluids. So you want there to be a liquid packed line. You don't want liquids trickling through the meter, especially with meters that are turbine meters or other meters that measure that velocity of that fluid, and you have to have that moving through quickly to get an accurate measurement. In throttling applications, a lot of people use throttling for oil and for water if it's not erosive applications. But you can choose which one you want to operate in, and it doesn't require any extra parts on the Gen 3. All it requires is that you change the position of the supply and vent on the level controller, and we'll walk through that here in a little bit on how to make that swap. We have both left-handed mount and right-handed mount for the Gen 3s. So looking at the front of the controller, if the controller is on the left of the vessel and you're looking at the front of the controller, we would consider that a left-hand mount because it's on the left side of the vessel. Even though that the connection would be coming out of the right side of the controller, we consider that a left hand, and you can see I've got it noted here on this picture. Some operating parameters for the Gen 3 with our standard displacer. has an operating temperature of 175 degrees Fahrenheit. If you are putting it in an application that's going to experience higher temperatures than that, I would suggest using our stainless steel displacer at that point. The caveat to that is you go from 4,000 pound working pressure down to 1,500 pounds. So the stainless steel displacer is a hollow displacer. It's actually more of like a float, like what we have on our level switches. And so that lowers the operating pressure to 1,500 pounds. So just keep that in mind. Make sure that you're not over that operating pressure, or it could crush that displacer. Connection types, we have a 2-inch MPT connection on all of our Gen 3s. If you are needing a flange connection, it's just an adapter. So it's the correct size and type of flange that has a 2-inch MPT hole in it. We can provide those, or you can source them yourself. But all the Gen 3 level controllers, whether they're right hand or left hand mount, all come with a 2-inch MPT connection. There's also a Cleanout port, which you can see it here on this picture. But I'll scoot this one over so you guys can see it a little bit better. There's a Cleanout port on the back end of the Gen 3 level controller. So as you're operating the Gen 3, you might have solid buildup, either paraffin or sand or other solids that build up inside of the neck of the controller. With previous versions of our level controller, you had to remove the unit from operations. You had to blow down the vessel. You had to take it completely out of service to clean that out. A good feature of this one is you can access that through the Cleanout port. You still have to depressurize your system, but you can. It's normally tighter than this, and you have to have a tool to take this off. But for demonstration purposes, I just have that hand tight. But this allows you access to the inside where the stem is at, and so you're able to clean out any solid buildup that's inside the Gen 3, and then reinstall, and then you can pressurize your vessel again and not have to take the Gen 3 completely out of service. It just saves time, and time is money. There's also a 40 micron filter on the inlet side. So when you supply this with gas or air, it's scrubbing out any solids out of the supply gas or air before it gets to the pilot inside of the level controller. One of the benefits of the Gen 3 level controller is that it does not vent inside of the housing. So no gas will be building up inside of the housing. When it vents out the vent port. It's a 1/4-inch MPT connection, so you can actually capture that vented gas if you are wanting to direct that to a vent capture system like a VRU or another low pressure gas gathering system. So you can make this emissions free by capturing that gas, or you can supply it with air instead of natural gas. So that way when it vents, it's just venting air and not gas. So when you're determining whether you want this to be snap or throttle acting, it's noted here, the S is for snap, and then the T is for throttle. There's 3 connection options. Vent is always going to be the opposite of your supply. So, if you make this a snap controller, then it's going to vent out of one of the top ports. You can plug one port and just have it vent out one. The output of the level controller will always remain the same. So you can see it's clearly marked here with out. So that's the output that will be going to the dump valve. And that will always remain the same whether you're in snap or throttle mode. The adjustments for the Gen 3 are all right here. So you have Every Gen 3 will come with a little Allen wrench to help you make the adjustments, as well as switch it from snap to throttle or change the action of the Gen 3. You can also remove the lid, keep that in a safe spot, don't lose it, but that just makes it easier access to the inside. So there's 2 adjustment points on the Gen 3 level controller. We've got the sensitivity adjustment here, and then we have the level, or you can think of it as like top level adjustment here. This is going to adjust your span, or the amount of travel that the displacer has inside of the vessel. And then this one is going to adjust the top level, or where you're controlling that level. Let's say you have the sensitivity adjusted to control 8 inches of liquid. So from the time that it opens, empties that liquid, to the time it closes, you're controlling 8 inches. If you adjust this, you're going to either widen or narrow that span. This one changes where that span is controlled. So let's say you're controlling 8 inches of span, but you just need that span to be lower or higher in the vessel. That's where you'll make this adjustment. So as you turn this, and these are noted in the instructions on the inside of the lid, as you turn that, the language we use is clockwise and counterclockwise in our installation manual and operation manual to make adjustments here. The Allen key that we give you can go in the hole here, gives you like a handy little spot to make adjustments. There's also flats on this that you can put a wrench and turn and make adjustments that way as well. If you have this in throttling mode, it's suggested that you start your sensitivity on the middle hash mark. So right now I'm a little bit away from that, so I'll adjust this to start pretty close to the middle. As you can see, that's a good starting point, and then make really fine adjustments from there on. If you change too much all at once, you may not know where you went wrong. So start in the middle for throttle applications, and then make fine adjustments from there. If you have this in snap orientation, we suggest starting all the way in. Start there, and again, make small incremental adjustments to get where you want to be. If you start on one extreme or the other, you could have trouble finding where it's going to operate well at. When you're deciding on snap or throttle control, we have a chart that notes where the position of the internals to the Gen 3 level controller need to be. It depends also on the failure position of your dump valve. We'll put a link in the description so you guys can follow that link and go to all of this information on our website and various blogs and technical documents. Next, I want to talk about the pneumatic level switch. It's just an on-off level switch. So whereas the Gen 3 controls a span of liquid that's adjustable, the level switch is exactly that. It's a switch. It's either on or it's off. The total liquid span that it controls is not very much. The total travel is just about under an inch. So again, you would use this in applications for high or low level shutdown. You can also use this in applications where you're limited on space. If you don't have a very large diameter vessel, you can see the projection from the 2-inch MPT connection to the end of the float is not very long. So it can fit in really small and tight places to control liquid level. As I mentioned before, and you can see on your screen now, showing the CUA level switch being used as a low-level shutdown on a line heater. The supply gas for this system is all run through the level switch. So if you ever lose liquid level inside of this vessel, it will shut down supply to the rest of the controllers on that system. So the burner will shut off. It's a safety feature in this application where we're monitoring liquid level, making sure it's above the burner tube and that the burner tube doesn't get exposed, that it stays covered with liquid and it's operating correctly. Our external flow cage can be used to position the level switch wherever you want external of the vessel. So if the connection for, let's say you were using a Gen 3 level controller, but you wanted to change the position of the liquid level that's controlled inside the vessel, you could use an external flow cage and position that at whatever level you wanted to control outside of the vessel. You can also use external flow cages, 2 of them, to achieve liquid gap control. So there's 2 separate level switches working in tandem, and the liquid level oscillates between those 2 level switches. There's an extra relay that you have to use in between the 2 level switches to get that to operate correctly. But again, just like our Gen 3 level controller, you only need 30 psi of supply gas or air to operate the level switch. The level switch has a 2000 psi working pressure. Because of the stainless steel, you can get up above 180 degrees in temperature of your fluid and not harm the displacer or the float in this case. Another feature of the level switch is that it has a manual override. The manual override can be used to test the function of the level switch without there having to be a change in liquid level inside of the vessel. So what you do is you push down on this manual override and it manually actuates the float inside. That way you can check your dump valve, make sure that it's operating correctly, you're getting supply gas or air through the whole system, kind of check it and test it. And it's very easy to check that function. Again, the vent on this is a 1/4 inch connection, so you can capture that vented gas, capture it into a low pressure system, a gas gathering system. We recently did a repair video for the level switch. We also have repair videos for the Gen 3. So I'd encourage you guys, if you're in the field working on these or maybe repairing them in-house, that you watch those repair videos. They're really helpful, full of tips and tricks on how to repair these well and how to test them. We can also leave links for those repair videos in the description of this video, so go check those out. We do have a electric version of the level switch, so it can be tied into automation systems, again used for high or low liquid level shutdowns. It's a low voltage liquid level controller, but again it has a manual override so you can test the function of it, especially if it's being used in a safety application. You want to be able to test that, make sure that it's operating correctly. If you click on our training and demos tab on our website, you can find a schedule training button, and that will walk you through the process of signing you up for in-person training. You can come to us or we can come to you, and we love training any size groups, so let us know what we can do for you. If you guys have other unique applications or scenarios that you've used these controllers in, we'd love to hear about it in the comments below. Thanks for watching.